Okay, class, like any school year in a science class, we're going to discuss and talk about laboratory safety and equipment. The beautiful thing about science classes is that we are able to physically observe and see the topics we're discussing in class. Laboratory experiments are loads of fun, but unfortunately, they can cause physical harm to students and teachers alike. This is why we must spend time to teach you the appropriate ways to behave in a laboratory each year. With all of my videos we're going to do in this class, I'm going to present you with an overall objective for the video. Our objective for this video is an easy one. It is that we have a generalized understanding of how to use basic laboratory equipment and to conduct ourselves in a way in which optimizes the safety for all of us within the lab. So in saying this, let's dive into our first video of the year. The first section of this video is going to deal with how to properly use common laboratory equipment. So to start off this section, let's talk about our gas outlets in the sink. As simplistic as it is, we need to understand how to turn on and off the gas outlets. If we accidentally leave the gas outlet running without knowing, then we can cause an accident that could end up hurting everyone within the laboratory. For this reason, make extra sure that you have the outlets closed. If the handle is parallel with the valve, then the gas flow is open. This allows the gas to flow through the valve. If the handle is perpendicular or makes a right angle with the valve, then the valve is closed and there is no gas flow. When in doubt, turn the handle perpendicular to the valve. Next to our gas valves should be some water valves. Just like your sink at home, you can turn the knobs and these turn on water. Be careful with the degree in which you turn these knobs though, because the water pressure is pretty intense. Lastly, with the laboratory sink and gas valves, do not stuff anything down the drains or in the valves. Laboratory equipment is expensive, and if you want to be able to do fun labs in this class, then we need working equipment. The next piece of equipment we are going to talk about is our Bunsen burner and rubber tubing. In order to get the Bunsen burner to work, we are going to have to hook our rubber tubing up to our gas outlet valve and to our Bunsen burner. Make sure the tubing is tight on both the valve and the burner. Now that the burner is attached to the gas outlet, we can turn on the gas, which should produce a slight hissing sound from our burner. At this point, we need to light our burner immediately. In this class, we're going to use small grill lighters to light our burners, opposed to a striker. You're welcome. Once we light our Bunsen burner, there are gas and oxygen adjustment knobs in which control the type of flame that is produced. In a later lab this semester, we're going to get to know our Bunsen burner better and practice adjusting these settings. For now, let's just leave you with two safety tips. The first is never point your burner flame at anybody. And the second is never leave an active Bunsen burner unattended. That is just a recipe for us to catch the school on fire. Another way in which we can heat a substance up is using hot plates. Think of these as high-powered mini stovetops. Each of these plates need to be plugged in and can adjust their knobs to your desired heat. Some hot plates have two knobs. The second knob is an adjustment for a magnetic spinner or a spinning plate. This in turn can help spin and stir magnetic stirring rods that we place within our liquids. In chemistry, we deal with a lot of different types of glassware, so let's clarify the different types there are. Beakers are the cup-shaped glasswares, while Erlenmeyer flasks are the pieces of glassware that almost look like an inverted funnel. Both these pieces of glassware have their own specific uses, but can be found in varying sizes ranging from 25 milliliters all the way up to 1,000 milliliters. Because of all these pieces of glassware that can be found in different sizes, it is important to specify their size. For example, a 500 milliliter beaker or a 250 milliliter Erlenmeyer flask. I don't just say get the beaker or get the flask. Another piece of glassware in which we will use in this class is test tubes. Test tubes are meant to hold small pieces of solid matter or amounts of liquid matter. Your safety rules for this piece of equipment is never point your test tube at somebody. We never know when an explosion is going to happen in chemistry class or chemicals are going to spew out, so it's better to be safe than sorry. We do not want to hurt our fellow classmates. Whether it is a test tube or Erlenmeyer flask, sometimes you may be asked to seal off the liquid inside of the glassware. In this case, we use a special material called parafilm. You can think of parafilm as heavy-duty saran wrap. You can stretch it over the top of a piece of glassware, twist it on, This should create a watertight seal in which isolates the system from being further influenced by the external environment. When measuring the mass or volume, we have two options in chemistry. To measure the volume of a liquid, we must use a graduated cylinder. Like most glassware, there are several different sizes of graduated cylinders. These are more accurate in measuring a desired amount of liquid than just relying on our flask or beakers. When we measure a liquid in a graduated cylinder, we see that the top of the liquid is curved downward. To be accurate in our liquid measurements, we measure from the lowest portion of the curve. This is known as the meniscus. Once we have our desired amount of liquid, we can pour it off into whatever container we are instructed to. If we are measuring the mass of a solid, then we are going to use a digital scale. If we are using a scale, it is imperative that we do not overload it or push down on the scale surface plate because this can mess up the calibration of the scale. This can result in messing up laboratory equipment for the year and hemorrhaging your grades because the measurements are not reliable at this point. The best way to weigh stuff out on a scale is to place weighing paper or a weigh boat on top of the scale weight plate without anything else in it. We then negate the weight of the weigh boat or weigh paper by hitting the zero out button. Now we can carefully add any substance we want onto the scale, slowly adding it until we have the desired weight or mass. If you overshoot the weight, do not put the excess chemicals back into the container, but instead put it into the chemical waste container. This will prevent any cross-contamination. Now, once you have weighed out your desired amount, you can pick up your weigh boat or weigh paper as so, then funnel it into the container instructed by your laboratory procedures. Next thing we're going to discuss is a crucible and a pestle. Your crucible is a bowl in which handles high amounts of heat that can be applied to it. A lot of the time, we either melt a substance in a crucible or use the pestle to smash or crunch it up. Another piece of equipment we're going to talk about is a watch glass. We can think of a watch glass as a giant contact lens. All it is used for is holding solid substances for observation or allowing that substance to dry out. When dealing with hot glassware, it is important that we do not use our hands to pick it up because that will most likely end up in burning us. If you do not know this already, hot glass looks the same as cold glass. So in order to pick up hot glassware, we are going to use tongs. Tongs are nothing more than these pincher tools in which separate your hands from the hot item. There are several different types of tongs designed to hold beakers, test tubes, and flasks, so make sure you grab the appropriate kind to perform the experiment. While on the topic of hot materials, let's talk about the ring stand setup. Ring stands consist of a base and a pole in which different clamps can be clipped onto to suit whatever purpose we need. These clamps' primary function is to hold glassware at a specific height. Whether it is a test tube clamp or ring clamp, we can use them to heat materials hands-free. When setting up a ring clamp, we need to make sure that our Bunsen burner is evenly heating the bottom of our glassware. To do this, we add wire gauze on top of our ring and below our glassware. As the gauze heats up, it will evenly distribute the heat along the glassware. In order to have one more step of protection and insulation from the direct flame, we can also put a clay triangle between the gauze and the glassware to help the heat distribution. Just like with your glassware, once you heat these items up, use tongs to handle them so you do not burn yourself on accident. There will be times in labs in which we have to measure out small amounts of liquids that would not be beneficial to use a graduated cylinder. In this case, we used a pipette. A majority of the time in the class that we use pipettes, we are going to be using 1 milliliter pipettes. In order to use these, carefully squeeze the bulb of the pipette while it is submerged. Then gradually release the pressure until the liquid suction reaches the 1 milliliter indicator inside the pipette. We then take the pipette out of the liquid and fully release the pressure on the bulb. It should come without saying, but we do not put pipettes or any lab equipment in our mouths or make janky water guns and squirt our partners with them. As we continue to go through some of our common lab equipment, let's address glass stirring rods and scoopulus. As the name tells, stirring rods are used for stirring liquid. The only thing I want to warn you against when dealing with these tools is that if you try to force them through something or drop them, they are probably going to break. They are made of glass. Now we got that out of the way, let's talk about scoopulus. Scupulas are used for transferring solid material from one holder to another. Just like a spoon, you can use your scupula to scoop out material, but unlike a spoon, scupulas have a funnel down in, which allows you to easily pour small amounts of solid out. Now that we have talked about some simple lab equipment in which you will be using throughout your time in my class, let's talk about some safety equipment. In the lab, you must always wear gloves. If for some reason your gloves tear, you must replace them with new gloves. We have plenty of them. Just remember, torn gloves are not a fashion statement, unlike your jeans. When conducting labs, we protect our clothes and our torso with a lab apron. This protects you from spills and is not porous, so chemicals will not soak through it. Finally, let's make sure we protect our eyes with goggles. Even if you wear glasses, goggles need to go over your glasses so they can protect your eyes from all directions. If you want to know anything about any chemical that we are using in our labs, you can consult the good old MSDS. This is the giant book found in our lab, or if you just look up online MSDS chemical name, that will tell us everything we need to know about that chemical, including how to clean it up if we make a mess. Okay, so now that we've gone through a bulk of this video, let's discuss a few safety rules to end us up. Because of the nature of these rules, I am going to list them off and say them. Honestly, this should be a lot of common sense and should not take too many brain cells to figure out here. Here we go. Our first one is be responsible in the lab at all times and do not mess around. Okay, so no horse playing in the lab. Next we have follow the written and verbal instructions from the teacher. As I've said, this is pretty common sense so far. Next we have do not eat or drink chemicals or food in the lab. We do not know what is contaminated and what is not. And let's be safe about what we're putting in our body. The next rule we have is keep your work area clean. Okay, going again with the contamination, keep everything organized and clean. We don't want to knock stuff over. We don't want stuff contaminated. We want good results here. Next we have be smart and do not directly inhale fumes. There's this technique we call wafting. If you do not know how to waft a fume, talk to me. I will show you. But do not just go stick your nose in there and sniff it. That is a quick way to get kicked out of my lab. Also, dispose of chemicals as instructed by your teacher or by me. I will have chemical disposal areas and tell you how to dispose of our chemicals that we use in our lab before we even start our lab. So pay attention to that. Here's some more no-brainers. Wash your hands after the lab and refrain from touching your face during an experiment. We don't want anything that could cause irritation to irritate any sensitive skin or mucosal membranes that are like close to your eyes, mouth, all that stuff. Okay, make sure you report all injuries or broken glass to your instructor. Here's the thing. If I find out about it from someone else, you're going to get in more trouble. If you just tell me, we can work around it. I understand accidents do happen. Oh, do not handle chemicals in a way not instructed by me. Also, never leave an active Bunsen burner or hot plate unattended. We don't want fires. And our final rule for today. Not all the rules, but this is the final one we're going over in this video. Do not place anything into a flame without a teacher's instruction. In chemistry class, there's a lot of stuff that can explode. And we will explode some stuff. But we need to be safe about that. Do yourself a favor and make a good habit of examining the glassware for chips or cracks before the lab. The last thing we want is glassware to shatter during an experiment, sending hot liquid everywhere. For the same reason, do not immerse hot glassware in cold water. The drastic change in temperature will cause the glassware to shatter or break. Finally, and our last one for today, and I am not lying this time, do not pour chemicals down the sink unless instructed otherwise. Some chemicals may react with the piping or substances within the drain. Because of this, it is safe to assume that most substances will probably have their own designated waste bucket, in which I will tell you about. Okay, you made it through your first video in this class. I know it's probably monotonous and seems pretty common sense. but we need to make sure everybody's on the same page and have the same baseline of expectations when we step into the lab. I hope you learned something about the equipment and heard some new rules in which you did not know in this video. In saying that, keep up the good work, and I look forward to seeing you in the laboratory this year. See ya.